And we are live. Thank you very much. Thanks everybody for joining. We're going to take a couple minutes to welcome people into the show.
Hi everyone.
And while we're doing that, why don't you introduce yourself in the chat and let us know where you are coming from. Tom is asking, is this just a text-only event? No, we just turned on live, so we're all here. Hey, Eve from Paris. Welcome. I actually just made my way up here. Hey, Ray from Taiwan. Awesome. Quite late where you are. Thanks for joining. Oh, early actually. Boston. We got Slovenia with Pavel. Oh, and Spain. Hi, Esther from Toronto. Vilmir from Macedonia. We have India in the house, Bolivia. That's really, really cool. And Sam from the SF Bay area. Hey, Suman. Hey, Sujit from Bangalore. All right. And London represents. Welcome, Anna. Welcome. So today is going to be Philip and I, Julien is not going to be part of this broadcast, so we're going to make it short and sweet, trying to fit it all within 30 minutes to give you time back in your day. We'll have many cool updates for you, and then an exciting demo from Philip.
Jeff, do you want to stop the music?
I will stop the music.
Yeah, I think it's hard to understand us if the music is running. Yeah. So.
All right. Well, then let's get started.
Yeah.
Hi, everyone. And welcome to HuggingCast V3. This is the third episode of our live show about open source AI. So if this is your first episode, what's this thing? We want HuggingCast to be a cross between a podcast and a webinar. We want to talk about the latest and greatest developments in the beautiful world of open source AI. And we also want you to walk away having learned something practical that you can apply in your work. So in each episode, we'll have a hands-on demo. And today, as I say, we're going to try to make our shortest show ever and keep it at 30 minutes. We're super excited to take your questions during the show, so don't hesitate to ask them while we're speaking, and we'll get to them when we have the time or at the end of the show. So I'm Jeff Poudier on the product team here at Hugging Face, and today I'm joined with my co-conspirator, Philip, and fellow caster, the hero of the demos.
Hey, everyone.
All right. Let's get started. I'm going to turn on the chat right here to see what's going on. So first, I want to give you some updates about the latest and greatest happening in Hugging Face. And first off, two great events and resources that you can take advantage of. We've recently released a new free course to learn everything about audio machine learning. And just yesterday, we released the 5th unit of the course that focuses on automatic speech recognition, so transcription. So it's a really, really cool unit. You can find all of our courses at huggingface.co/learn. Let me flash the page for you so you get a sense. There you go. So, of course, you may be familiar with the Transformers course, our NLP course. We recently published the Deep Reinforcement Learning course, and now the audio course. So I invite you to check it out. And the latest units, as I said, are published yesterday. So next, I want to talk about a very cool event that's upcoming. That's going to be in just 10 days. The Open Source AI Game Jam. And what this is an invitation for the community to come together and build a great game using machine learning in just one weekend. It's open to everyone. It's free for everyone. So if building games is your jam, then subscribe to the Hugging Face Game Jam. And that's it for the events. Next, I want to tell you about some exciting developments over the last few weeks. And maybe I'll start with Clem, our CEO, Clément Delong, his testimony in Washington, D.C., to sort of represent the voice of open source AI and open science. And I thought that was a very, very cool, very, very cool testimony. You can watch the whole 5 minutes thing. I actually have it over there. Let me play you a quick clip from the excerpt that's published on Twitter.
Maybe Jeff, can you tell the ones who are not familiar, you are talking about what is this about? Like, what did Clem do, or like?
Yeah, definitely. So there's currently a lot of efforts from regulators, policymakers to make sense of AI and understand how to best regulate it, how to best enable it. And as part of these efforts, some of the key contributors to AI have been invited by Congress to provide testimonies and share their point of view. And that was the object of this testimony. And yeah, maybe the best thing is to just play you a couple seconds from it.
First, it's good to remember that most of today's progress has been powered by open science and open source. Like the attention.
Okay, I'm having bandwidth issues, but I think it was a really important testimony that put forward everything that the community has been building together and bringing together to get us to where we are today, right? All of the great models that the Transformers library enables you to access. Everything comes from this collaboration of researchers, data scientists, and machine learning engineers. So it was great to have that sort of voice be spoken in front of US regulators. And another accolade, and this time around, I don't have my disco ball, so I can't bring up the prop. But we were very excited, I think it was this week or last week, to see Hugging Face recognized as one of the top 100 companies by Time. I think I have the link over there. There is the link, and let me share with you the page on Time. So really cool profile and a great honor, not just for us, but for the whole community that's been contributing to collaborative AI. Over 200,000 models now available in our libraries and in the Hugging Face hub. And last company update, and this one is more relevant to businesses, which is that we recently received our SOC 2 Type 2 certification. What is this thing? This is a stamp of approval to show that our hosted services, so the hub, is compliant to the highest standards of security, which is really important for our enterprise users. So super excited about this new certification, which brings me to the product updates. And I have 3 product updates for you today. And the first one is the Enterprise Hub. And what is the Enterprise Hub? It's the same Hugging Face hub you know and love, but with additional sort of security features like SSO for access control, like additional security features and the ability to sort of manage your billing across your organization. So if this is something that rings true for you, then do check out the Enterprise Hub. You can find it at huggingface.co/enterprise. Cool. So that's the first one. The second thing is a new feature that just shipped in Spaces, and it's the ability to set up persistent storage for your spaces, which is really, really cool for a lot of use cases like data annotation or many others. And just like with hardware upgrades, we make it super easy. It's a click-through experience to upgrade and get some persistent storage for your spaces. And last product update, I want to tell you about something that I'm really excited about because it was the #1 requested features for users of Inference Endpoints, which is an easy experience to take any model on the Hugging Face hub and then deploy it on dedicated infrastructure just for you. And we just shipped automatic scale to 0. So you can find it within the advanced configuration and then can set up today to scale to 0 if there is no requests incoming within 15 minutes of your endpoint. So scale to 0, that means you're not paying for the infrastructure anymore. A great way to save money if you have intermittent sort of workloads. All right. So that's for the product updates. And then I want to give a shout out to our newest partner, AMD. We announced just a week or so ago a new exciting partnership between Hugging Face and AMD to make it easy to use our models, our libraries with AMD platforms, and starting with AMD GPUs. So super excited about that. What you can expect from us is a new open source package to make this experience very easy, and a great support for our most popular models on AMD platforms. There was actually a really, really cool event in San Francisco I was lucky to be a part of, where Clem, our CEO, came on stage to talk about our partnership. Julien Simon has a blog post on it if you want to learn more about this. And that's for the updates. The updates I wanted to show you today. I'm excited to move to the most exciting part of the show, which is the live demo. And maybe before we get there, I want to hear from you, Philip, about like what's the latest and greatest in the world of open source large language models.
Yeah, so I guess since the last time we talked or did a HuggingCast session, a lot of came out or got added to the open source leaderboard and to the open source ecosystem. Yesterday, Salesforce has released their X-Gen models, which is let me open it. Which is a llama-based model, but it's like a bit different to like the open llama reproduction, since it was trained on 8,000, meaning that you can like now use all of the llama ecosystem. Is it llama CPP or local GPT-4 or whatever, with the new X-Gen model, and have available context length of 8,000, meaning that few-shot prompting or having like conversational model got way easier, and the model performs equally well as the llama model. I think Open Llama released their 14B model, so a lot of new open source LLMs keeps coming, and I think we slowly but surely closing the gap. I mean, it's still a long way, but of course we know that like we rather have special certain use cases which are cheaper to run than like this one super powerful big model. Which I might not have the GPUs available anyways. And then something super interesting. So the team behind the Open LLM leaderboard released a blog post last week talking about what's going on with the Open LLM leaderboard. And I think the most interesting part about it is that people asking, okay, why are we reporting Llama 65B? Or why are we reporting different values than the Meta team has reported in their paper for the MMLU benchmark? And the blog post talks about what the Open LLM leaderboard is. So for the ones of you who haven't seen or heard about it, it's a Hugging Face leaderboard with all of the open source available LLMs on Hugging Face, and those are evaluated against a standard set of benchmark from Illuthor AI called eval harness. And in there, we see that currently Falcon, for example, is the overall best model. We have the Llama models in there, but we can also scroll down to smaller models where we see Llama, Alpaca, 13B, 7B, and there are a bunch of more models. And it basically should help you get started. Okay, which model should like I pick to fine tune or to use for my application? And what is super cool about that it's basically a community effort. So if you trained a new model, or if you want to add a new model to the leaderboard, you can basically submit it here. The only requirement is that the model is available on the Hugging Face Hub. And then you define basically your revision, and then the model is run on the Hugging Face cluster with the same set, than all of the other models, which makes it basically comparable. And I think that's exactly what the blog post is about, that you always need to be careful about when like reading papers or seeing benchmarks, since it seems that everyone is doing kind of the same but different. So for example, for the MMLU benchmark, there are 3 different implementation of the same benchmark, and all of those 3 different implementation have different results for the models. So the original MMLU benchmark from Berkeley creates different results than the MMLU part from the Stanton. And there's also like the 3rd implementation from Illuthor AI, and everything is basically documented. And if we check the differences, so we can see for the Llama, here we can see like the top Llama model. So the Hugging Face team has used all of the basically 3 MMLU implementations, the top models against it. And here we can see that on the Helm MMLU and the original one from Berkeley's Llama basically stays the best model, and on the MMLU from Harness, which is like coming from Illuthor AI, and which was also the one used on the Open LLM leaderboard, we can see that Falcon is outperforming Llama, and everything like exactly documented. What's the difference between all of those? How are they prompted? What is the few shot? How many few shot examples are used? I think it's like, if you are interested in like really how LLMs are evaluated, want to see, okay, what's the difference, then like definitely check out the blog. Highly recommend it. And then I think also, since the last time, the Open LLM leaderboard got a bit of a hidden extended view. So normally when you open the leaderboard or the space, you end up the LLM benchmark Lite, which has basically the eval HAL, so now an extended view, which has an additional column for the type. So if the model is already a fine-tuned model, so instruction models, for example, are fine-tuned model, and there are pre-trained models which are not yet fine-tuned, we have a column for licenses. So that way you can like make sure, okay, is the model I saw on the top performing benchmark, is it usable for commercial use cases? And if we check for the best average model, we can see, okay, Falcon is under Apache 2. But for example, if we look at the Llama 65B, it's under another license, which we know that Meta AI has commercial use for the model. We also have a new column for parameters, which makes it easy for you to also search and filter for, okay, which model size can I run and can I use for my application? We have a column for the likes on the Hugging Face Hub. And then again, the similar columns we have from the first tab, basically.
And so at the top of the leaderboard is still Falcon 40B, right? And I know we're getting a ton of requests from customers on how to deploy it. So what are the best options today if you want to deploy Falcon 40B on your own sort of endpoint?
Yeah, so let's go to the Falcon 40B model card. So that's basically where you can start when you want to deploy it. And if you go to deploy, we currently have like Inference Endpoints, Amazon SageMaker, and SRML. And I think we are now going to show you how to deploy it with Inference Endpoints, which is our managed SaaS, run the infrastructure for you. which is a lot for Falcon 40D. Then there's also the Amazon SageMaker way, which we're also going to show you how to deploy the instruct Falcon model into your AWS account. And then there's also Azure ML. We are currently working with Azure to enable it. So if I would go to Azure, it would basically show, okay, model currently not available, so for Inference Endpoint, I think that's probably the easiest solution. So you don't need any coding experience, any knowledge at all about machine learning. The only thing you need to do is to have an Hugging Face account and have your credit card added, and you can like click on deploy an Inference Endpoint, and then you can basically already create the endpoint. But what we want to do now is, since I have access to A100s, which you can also request if you're interested or not having the quota, and we deploy on the A100. Additionally, we want to make sure that we have int8 quantization enabled, since the Falcon 40B model would be too big to fit on a single A100, 80 gigabytes. So quantization needs to be enabled. And then when we click create, and now the endpoint is created, which should take around 5 to 10 minutes, since we need to download the model, start the instance, and also make sure the model is loaded. And for Falcon 40B, it takes quite a while to load the model into memory. While that's done, we can look at how you would do this with SageMaker. Going back to model card, we can also go to deploy and into Amazon SageMaker. And here we get a code snippet for how you could deploy the model to SageMaker. So basically what you could do here is copy it, put it into your Jupyter Python script where you have your AWS credentials available, and then run it, and the model would be deployed. I already prepared a notebook for it. It's basically an example. We have created how to deploy LLMs to SageMaker. So we have created with AWS a new Hugging Face container for deploying large language models. And the container is based on the text generation inference we have at Hugging Face, and it can be used to deploy basically any open source LLM model, including Starcoder, Plume, GPT-NEO-X, Llama models, T5, and all of the other models basically. And what is super cool about text generation inference, that it handles all of the heavy lifting for running LLMs for us, meaning it includes tensor parallelism. So if my model view, we automatically shot it before loading it and then distributing it on the GPUs you have available. We wrote special optimized transformers code for inference, including flash attention, for example. So if you're running on newer GPUs, you can benefit from flash attention to reduce your memory needed to run large generation. We have support for quantization. We have continuous batching support, which allows us basically, or you, to get the maximum throughput through the application, and then a lot of additional features. What is super cool and definitely promising is the watermarking features, that you could enable watermarking, which enables you to see, okay, was the code or the text generated by an LLM or not? So that's definitely interesting as well. Okay, what we need to do to deploy our model, we need to install the SageMaker SDK that's basically used to create our endpoint. And then the first thing is to set up our permissions. For the ones of you who haven't seen SageMaker, so that's basically a code snippet to gather permissions to be able to deploy resources on the AWS cloud. And then, as mentioned before, we created this new Hugging Face LLM container, and here we are going to use a utility called get Hugging Face LLM image, where we specify the version. Currently, we are going to use 0.8.2. And then we get back an image URI, which is pointing to our deep learning container. And then, similar to what we have seen in the snippet, we are going to use the Hugging Face model. We define the instance type, a G512X large instance, so not an A100. But we are still going to deploy the 40B model. The G512X large instance comes with 4 NVIDIA A10 GPUs. So we are going to split our model on all 4 GPUs. We define our number of GPUs for the tensor parallelism, and then we also set an initial health checkout. Basically, going to run a super big model. It takes some time to start the container. Please wait 5 minutes before trying to see if the model is available. And then we have our model configuration where we say, okay, that's the Hugging Face model ID. We have our numbers of GPUs. And then also something with check generation inference is we need to tell the solution basically before what is the maximum input length and the maximum total tokens generated. That's basically there to help to help you avoid any out of memory issues. So if you are familiar with GPUs, you probably have single CUDA out of memory issue. And by using those boundaries, you can basically secure, okay, if any customer is using your instance, they cannot generate more than for example, 2048 token. That basically avoids any out of memory issues for your endpoint. Of course, first you need to make sure if the values are correct. So before that, you validate those values. So for example, if we use StarCoder, which has a context length of 8,000 tokens, we could set the max total length to 4,000 token, for example, and then validate, okay, is 4,000 enough to not run out of memory? Or is it, should we decrease it? Or maybe you want to keep it low on purpose to I don't know. But that way you can basically configure your endpoint. Also, if you would like to use the quantization feature, we have basically enabled through the UI in Inference Endpoints. You can define it here, and all of you can find on the text generation inference GitHub repository. Then we need to create our Hugging Face model class instance, which is basically a configuration holding our AWS permissions, the image, and our config. And then we can run the .deploy method, which creates our endpoint. I have done this already shortly before our 5 to 10 minutes. So we can try our model. Here in the run inference section, you can also see all of the hyperparameters you can use for generating. So you can set the temperature, you can set the seed to make sure that you can reproduce your generations. You can set stop tokens. So if you want your model to stop on a certain token, you can define those, everything documented. I think we can share the link in a minute again. And now we can test our model. So what can I do in Toronto? And our model says there are many things to do in Toronto. Some popular attractions include the CN Tower tops. Maybe I'm missing some parameters. That's where we can try to add our parameters and increase the max new tokens to make sure that we get the full suggestion from our model. So let's try again. This time I ask, what can I do in Toronto? Give me 3 tips to be a bit more specific. And the 3 tips are visit the CN structure in the Western Hemisphere. Not sure if that counts when looking at New York. Maybe that counts for Canada. We can explore the distillery district and check out the Royal Ontario Museum. Awesome. And what is super cool about the Falcon 40B instruct model, it is also trained on conversational. Meaning that we could easily create a chatbot using Cradio. So I prepared some small little Cradio application, which has basically the chat interface and uses our model to send requests to. So we are still using our SageMaker endpoint and create an application. And now we can start asking something about AWS. Make sure it's English. Okay. What is Amazon SageMaker? And what do we get back? Amazon SageMaker is a fully managed platform that enables developers and data science machine learning quickly. I guess that's correct. And then it provides a range of tools and services, including pre-built algorithms, pre-trained models, and a fully managed environment for training and deploying models. Amazon SageMaker also integrates with other AWS services such as S3, EC2, S3, again, to provide a complete end-to-end solution for deploying machine learning models. Awesome. Okay, and then I think we just need to make sure that we stop our instance again, since SageMaker is not yet having auto-scaling to 0 for GPU instances. And I think
that's super cool.
Looking at our endpoint, what we can see, waiting for the model to be started. All right.
We did it right on time, 30 minutes on the money. Thank you so much, Philip. There are a few questions out there that
Yes.
I haven't answered yet in the chat. So one was, do we know what the context window for Falcon 7 billion is?
Yeah. Yeah. So far, both have 2048 as the context window, so sadly not that big.
Nice. And then another question was, what is our best option for fast inference? And the question was about like which instance, but I know the instance is not the only parameter, like quantization can play a part in it. So what would you say is the best setup for fast inference?
I think it really depends on how much resources you have available. So there are like always different things to optimize when you like want to achieve faster latency. Definitely, if you have like access to currently H100 or A100s, that's like the easiest like way to use the best hardware. You get some performance improvements compared to like older generation hardware. And then using tools like text generation inference or Optimum to optimize your model, meaning you can, like as Jeff mentioned, quantize the model. You can use a faster or better implementation for kernels. So, for example, flash attention is something where we generation models. We also seen new ways for the attention mechanism. So there's like the default one is multi-head attention, but we see new models like Falcon using multi-query attention, which also reduce the memory needed for generation, which allows you to have like bigger batch sizes. So it's not, there's no, I would say, single answer to it, but I guess the best way, it really depends on what you have available. If you can upgrade your hardware, that's probably a good step. If you are not already using an optimized inference toolkit like text generation inference, then it's definitely a good way to get started. So moving from like a fast API transformers generation to text generation inference should give you like easily a 2x speed improvements through all of the optimizations we are doing. And then if you are like, I would say, experienced and interested in like low-level optimization, you can like look at OpenAI Triton to write your own kernels to fuse operations or improve the modeling code to have like less copies between like CPU and GPU.
That's awesome. Thank you so much. Maybe another last couple questions. So Shrithran was asking, will Hugging Face offer instant service in the future like Lambda AI?
I think we already kind of do, no? Like we now have like spaces who has like hardware upgrades where you can like select CPUs, GPUs. We have our persistent storage. We have support for container, meaning that you theoretically could create a space with a GPU and a persistent space to run your Jupyter notebook, and then stop it if you don't need it. You can make your space private, so you can only organization or your user. So I think it's already doable.
And then I had a question about from Mattia about, are you planning to make leaderboards according to language as well? That's a great question. We just added a bunch of features to the leaderboard, which Philip shows, so you can easily see the license, the popularity through likes, etc. I think languages would require some specific sort of benchmarks. So definitely a question that you should ask in the community tab of the leaderboard space, where you can ask questions to the spaces creators and the community. Cool. Well, I think that's going to be it for this show. Thank you so much, everybody, for tuning in. This is, of course, recorded and will make it to our YouTube channels where our previous shows are living today. Thanks so much, Philip, for the great demo. Now it's up to you to deploy your own Falcon 40 billion large language model. Until next time.
Bye.